All right, welcome back to Mr. P Helps with Calculus. This is Unit 2, Day 15, our final lesson of this unit. And we're going to be talking about whether or not a function is continuous or differentiable. Two things we basically have kind of covered in the past, but we're putting them together, to be honest. All right, so continuity just means that a function is continuous, meaning you could draw the function without picking up your pencil from left to right or right to left. It really doesn't matter. That's continuous, meaning there's no holes, there's no jumps, there's no breaks. A function is all one continuous piece. Differentiability means that a function is differentiable, which means that a function can't have any corners, any cusps, and it can't have any vertical tangent lines. Now, what that basically means is that a function must change its slope over a slow process. In other words, it cannot infinitely change from going down to going up instantaneously. Can't do that. It's got to change gradually. That just means over small little amounts. So in other words, at every point on the entire function, every point on that interval, every place has to have a limit from the left and the right hand sides. Has to have a limit where it's going to be the exact same. It's going to be approaching about the exact same amount. Well, that's essentially how you're going to test for differentiability. It says a function may be continuous but may also not be differentiable. It is possible. Now, all functions that are differentiable have to be continuous. We should already know that by now. So first thing I can do is I can prove whether or not it is a continuous function. Is this point right here, which is the one in question, is this point continuous? Well, it does have a clearly defined answer. It's not a hole. So f of 2 is 0. The limit, both sides are approaching 0, and they happen to be exactly the same as each other. So yeah, in red here, we can see that, yes, this does meet. It is a continuous piece right here. But is it differentiable? No, it is not. And I know it's kind of obvious. One piece is coming in and approaching from above, and one is approaching from below. So therefore, these two pieces make what's called a corner. So essentially what that means is if I take a point that is just to the left and see what the limit is that approaches 2 from the right and from the left, these two should be about the exact same slope. Now I say they should be approaching. If I use a calculator and plug in 2.0001 for a number that's slightly to the right of 2 and put a number that's slightly to the left of 2, you should get two answers that are pretty much the exact same. They don't have to be exactly the same. They have to be approaching about the exact same number because slopes can't just change instantaneously. They have to change gradually. So clearly the left and the right hand sides are not the same, proving that this is not differentiable. All right, so now same thing with this question, but the difference is on the left and the right hand sides, although it might be continuous, it's not going to be differentiable because that is a vertical tangent line. So that's a pretty simple one for me to explain. It's going pretty much vertical right here at 0. So that is not differentiable in that question. All right, so here's a piecewise function. This is a very common question that you're going to get. You're going to get a piecewise because this left piece and this right piece, although they may or may not be continuous, even if they are continuous, it might not be differentiable. It just kind of depends on the question. And that's why we do what we do. First thing I'm going to do is check to see if it's continuous. Does f of 4 exist? Well, you have to use the top piece. 4 here does equal 16. So clearly, yes. If I put 4 down here, I also get 16. So yeah, they are both 16 at 4. So yeah, the limit for the left and the right, they both do happen to hit the exact same place, and these two happen to be the same as each other. So yeah, got that out of the way. Yes, it is continuous. This is quadratic. This is linear. So those two pieces are also going to be continuous on their entire domains as well. So we have checked to make sure that they are also continuous at 4. That is the one point that we had to worry about. Now, is it differentiable? We know it's differentiable if the left and the right hand sides have about the same slope. So I would start with something on the left of 4 using, okay, this is a slightly different way of doing this. Since this is a piecewise, we actually have two different functions. So what we could do is use our f of x minus f of a over x minus a function. And that's actually going to be a lot easier than doing it using your calculator and trying to put in numbers that are slightly less. So using this, I'm going to use f of x, which is x squared, minus f of a, which would be 4 squared, over x minus a. And then what I can do is I can, at the top, I can simply factor it. I can factor it into this. Clearly, there's the whole I'm getting rid of. So I'm left with just x plus 4. Plug 4 in there. 4 plus 4 is 8. Perfect. Left side is approaching a slope of 8. Now let's do the same thing for the right-hand side. So let's do the exact same steps. So that's f of x. That's the original function. That's f of a, because 4 times 4 is, I could just put 16 there, to be honest, over x minus 4. Now I'm going to do this a little bit differently by factoring out the 4. Both these terms can both be divided by 4. It gives me this. And the reason I did that is so that, boom, I can cross out the x minus 4 on top and bottom. And I'm left with just 4. So if I plug 4 in for x, then I get 4. Because obviously there is no x anymore. So the answer is just 4. Are these two the same? Is the limit from the left and the right-hand sides the same? Are they approaching the same slopes? No, they are not. So this is not a differentiable. This is, once again, going to be considered a corner. One's going up by a slope of 4. The other one's only going up by a slope of, that's really hard to do. It's going to look something like this. I know it's inverted. One piece is going to be going up very fast on the left, and then it's not going to be going up as fast. So it is going to create what's going to be a corner. So here's x squared all the way up to 4, and then it's going to go like this. That's kind of a visualization. Gives you a little bit of a rough idea of why this is a corner. All right, next one. Once again, another piecewise function. First, I'm going to check if it's continuous. Plug 0 into the top piece. 5 minus 0 is 5, so that does exist. This 5, let's see. What are we doing? We're doing 0. I forgot. 0 squared is 0. 0 times negative 2 is 0. Wait a second. This one has a height of 5. This piece has a height of 0. The limits do not meet. That is clearly a jump, and these two are not the same. So this is not continuous. Well, that's a great question, because if it's not continuous, by definition, it cannot be differentiable, because anything that's differentiable must be continuous. That is a part of the rules. All right, example number 3. One more that we can go through. Clearly, this is a yes for both. That's something we haven't had yet. A continuous, if I plug 2 in here and I plug 2 in here, yes, it looks like we get the exact same thing. We get 5 for both. Therefore, yes, it is continuous. Yes, on the exam, you must do what I'm doing. You must use 3-point continuity tests. You don't have to actually label it 1, 2, and 3, but I always do because that's just my habit. Then I'm going to do whether or not it's differentiable. Yes, you must show it. And this is one of the things that students by the end of the year probably forget how to do this. This is something you have to go back and relearn again at the end of the year. To prove it's differentiable, you must prove that the limit on the left and the right are matching. If they're not matching, the slopes don't match, then it's not differentiable, and that will be a corner. Has to be pretty much the exact same slopes. So let's see. The left-hand side is this quadratic. F of x minus f of a over x minus a. Simplify that down to this. Factor this into this. Cross it out. Plug 2 in for x. 2 plus 2 is 4. Okay, not too bad when you break it down step by step. Same thing with the right-hand side. You've got this linear piece. F of x minus f of a. If we plug 2 in for x, 4 times 2 is 8. 8 minus 3 is 5. So this is really just 5. Over x minus a, which happened to be 2. Remember, I already told you this is 5. Negative 3 minus 5 more is negative 8. That got me to here. Factor out the 4. Works perfectly. Boom. The indeterminate solution of 0 over 0 is gone. Plug 2 in for x, and you just get 4. 4 is the answer. They both, the left and the right-hand sides, ended up being 4. So, yes, this is differentiable. And that was my last example. Hope this helped. Thanks again for watching. I'll see you on the next video.